of the dt times un.
Okay, yeah, I will. Here you mean you want me to repeat the derivation?
يس كمان قبل يس من هون لأنه صار في لاج فكرته من
Okay,
عندي.
okay, no problem. Yeah, I will. Let me open another. I will open a new sheet and explain it. Okay. So if you move on a curved line, so let's say you are moving on a curved line, okay? Then you want to consider what is dut by dt. This is your purpose, okay? This is why what we will do, we will say, we will take analysis of a very small displacement. So let's consider, for example, your particle was here, and it moved a small angle to this position here, okay? As we said, when you are moving on a curve, then you can consider that at each, for a very small displacement, you are moving on an arc of circle. So here in red, I will represent the arc of circle. Okay, so let me put it like this. So I'm moving on an arc of circle here. Okay, since I'm moving on an arc of circle, I can try to find my center of curvature and say that for the small displacement, I am moving along a circular path about center O. Okay, O is called the radius of the center of curvature, and in general, the radius of curvature is called rho. So let me represent the radius here. This is the radius of curvature at the first position, position 1, and this is the radius of curvature at position 2. Now
دكتور
what
بس راح
happened?
السكرين شير.
راح السكرين share. Okay,
Yes.
let me share it now. Do you see it now?
Yes now.
Do you see it? Okay. Oh. So as I was talking about the two positions, you are moving from one position to a very close one. You are turning a small angle. This small angle is called angular displacement. So this is d theta. Okay. This angle here is d theta. And since we are working in normal tangential coordinates, so I will represent vector ut un at position 1 and position 2. Okay, so you have that ut here. Ut is always perpendicular to the path. Okay, so tangent to the path, sorry, and perpendicular to the radius of curvature. So this is ut at the first position, and un is this one. Okay, is perpendicular to ut along the radius of curvature directed towards the center of curvature. So this is your un ut at the initial position. So if I want to write here, this is ut and this is un. Okay, now since you are interested in dut, you will find what will be at the new position, how will change my frame. So at the new position, if I select another color, so let's say I will take it in. Okay. So here you have at the new position, this is ut. Ut is tangent to the path, and un is uh, perpendicular, of course, to UT, directed towards the center of rotation. Okay? So here I represented UN UT at two positions. So this is, we call them UT prime and UN prime. Okay? Now, what is happening is that I am interested in DUT. What is by definition vector DUT? So let me write this. Okay. What is DUT? This is the variation in UT vector. So it's equal to UT prime minus UT. Okay? Now, if I want to draw it in a clearer way, I have that this is UT and UT prime. If I represent them on a bigger scale here, you have this is vector UT at the first position. Okay. And this is UT prime. And what is the angle between UT and UT prime? هلا حكبر الانجل شوي تتقشعوها. What is the angle between them?
دي ثابتة.
دي ثابتة because لأنه مثل ما قلنا UT perpendicular ل UN, okay, و UT prime perpendicular ل UN prime. And the angle between U and UN prime is equal then to the angle between UT and UT prime. So the angle here is also d theta. Okay, so this is angle d theta. Now, where is my vector DUT here? My vector DUT is this one. This is DUT. Okay, this is DUT vector. Because by definition, DUT is the difference between UT prime and UT. So UT vector plus DUT will give me UT prime. And as you can see here, you can verify this. So this is in blue, you have UT plus DUT will give you vector UT prime. Okay? So here, this is my vector DUT, which is the difference between UT prime and UT. Now, once I have drawn this triangle, this will allow me to find the properties of DUT. Okay, so the first thing I can say is that I know that UT and UT prime are unit vectors. So their magnitude is 1. Okay, so the magnitude here is 1 and the magnitude here is 1. So I have here an isosceles triangle. Okay, and then since d theta, this angle here is very small. So this is d theta, but d theta is tending to 0. Okay, because d theta tends to 0, this means that I can consider that segment DUT is nearly equal to the arc of circle. So since d theta is nearly 0, okay, then I can say that this segment DUT can be calculated, the length of this segment can be calculated by the arc of circle here, this arc of circle. Okay, what is the length of this arc of circle? It's the radius times d theta. So this one has a magnitude 1 times d theta. Okay, and then the magnitude of DUT is d theta. I am done with the magnitude. I still need to talk about the direction. Okay, so we know that we said that this is an isosceles triangle and that this angle is nearly 0. So what will be the angle here? لأنه it's an isosceles triangle حيكونوا هون two equal angles ولأنه هذا الانجل nearly 0, this means that the angle between DUT and UT is 90 degrees. So what can I deduce from this? Is that DUT perpendicular ل UT upward, يعني هي parallel لمين؟ هي collinear and having same sense of UN. Okay, يعني UN, if I draw UN vector حيكون unit vector تبع دي يو تي لأنه هو perpendicular ل يو تي upward مثل دي يو تي here. Okay, so now since I found the unit vector of the UT and I found the magnitude of the UT, I can now write that هلا أكيد هون كلهم vectors. Okay, vector. So all of these are vectors. Okay. So now I can deduce that vector dut can be written as d theta times un. Okay. So now I can write that this is equal to dut equals to d theta times un vector, of course. Okay. And now, once I obtain this expression, Anna, what do I want to find? I want to find dut by dt. So I should divide this result. If I divide it by dt here, so I divide here by dt, I divide here by dt, and here by dt. What do I get? I get that dut over dt is equal to d theta by dt times un. Okay? Now, what is d theta by dt? This term represents what? This is called the angular velocity. Okay? This is the angular velocity omega. Okay? And we know that from circular motion, okay, d theta is here, as you can see. D theta is the angle of displacement on this small arc of circle. Okay, so d theta by dt will represent the angular velocity of rotation around O. And you know that in circular motion, how we can relate angular and linear velocity? We say that omega is equal to v, the linear velocity, over the radius of curvature, rho. Rho is the radius of curvature here. So here, the radius of this circle here is called radius of curvature, is rho. From here, I can replace d theta by dt by v over rho un. Okay? And now, if you go back to your expression, so do you see again the PDF or no?
Yes, we see.
Okay. So if you go back to this definition here, a v by dt vector, and v vector is v times ut. So if you derive it, it's u prime v plus v prime u. Okay. So it's dv by dt ut. dv by dt is due to the change in speed, plus v dut by dt. Now, if you replace dut by dt by d theta by dt un, and you replace d theta over dt by v over rho, what do you get? You get v times v over rho un, which will give you v square over rho un. So your final expression is that the acceleration has two components, tangential and normal. The tangential component is due to change in speed. The normal component is due to change in direction, and its magnitude is given by v square over rho. Okay. So let us continue now. So in general, as we said, whenever we have curvilinear motion, we will work in UNUT frame because it will be easier. And then we have AT is defined by change in speed, while AN is defined by change in direction and is equal to v square over rho. Now, keep in mind that all relation developed before, okay, R was for tangential acceleration. يعني نحن بس كنا نحكي عن constant acceleration ونقول إنه V equal V0 plus A constant times T. If we are dealing in curvilinear motion, هيدي acceleration هون is the tangential one. Why? Because when we derived together these relations, we based ourselves on what? We said that A is equal to dv by dt. Okay, And in rectilinear motion, we don't have normal acceleration. We only have a tangential. This is why we didn't specify this is a tangential. But now, from now on, when you have a curved motion, you should specify dv by dt is not total acceleration, it is at. Okay? So when you are working in curvilinear motion, dv by dt is at, and in case I have constant at, I can apply all the relations we developed together before, for example, as equal as 0 plus v0t plus have a constant t square. This constant acceleration means at, a tangential. If I have the total acceleration constant, I cannot use this formula, because these formulas are only valid if the tangential acceleration is constant. Okay, so if at is constant, I can write that v equal v0 plus at, a tangential times t. I can write that v square final equal v square initial plus 2 tangential acceleration times delta f. Okay, so keep in mind only if at is constant, not the total acceleration. Okay, لأنه if the total acceleration is constant معقول يكونوا an و at variable. So this does not mean انه if total a constant يعني at constant. I should verify that at is constant to be able to apply these relations. لأنه هول relations are developed based on dv over dt constant. Now, we have seen together that an is calculated as v square over rho, okay, where rho represents the radius of curvature. But how to determine rho? So, in general, we said that the easiest example is a circle. If I have a circle, rho will be equal to the radius of the circle. But in other cases, if I have a curve, how to determine the variation of rho? Rho will be variable. So if I have a curve, one method is to find the radius of curvature rho is to give me the equation of the curve. So if they give me the equation of the curve in a frame, y function of x, I can calculate for any position x what is the radius of curvature by using the following formula. So this formula will relate the radius of curvature to the derivative of y with respect to x, first and second derivative at any point. So هلا we will take an example. If I give you the y function of x, you can calculate for any x what is the radius of curvature using the following relation, which is 1 plus dy by dx squared, the whole term to the power 3 over 2, over the absolute value of the second derivative. Let us take an example. When the skier reaches point A along the parabolic path, he has a speed of 6 meters per second, which is increasing at 2 meters per second squared. Determine the direction of his velocity and the direction and magnitude of his acceleration at this instant, and neglect the size of the skier in the calculation. So what do we know here? Let me zoom it a little bit. What we know here is that the skier is moving on a path of equation y equal to x squared over 20. Okay, so this is the equation of the path. And we know in particular that when passing by A, he has a speed of 6 meters per second. So VA is given, okay? And this speed is increasing at 2 meters per second squared. This sentence will give me what? That the speed is increasing at 2 meters per second squared.
The acceleration.
Tangential acceleration.
Yes, the tangential acceleration. انتبهوا مش total acceleration. It will just give me the tangential acceleration. Because here, the tangential acceleration by definition represents the change in speed. هنا عم يحكوا عن speed increase. Speed increase يعني عم يعطوني 80. بما انه it's an increase, so it's an acceleration, then V and A will be of same sign. ونحن قلنا إن UT UN V is always positive لأنه نحن we define UT based on velocity. So here, since velocity is downward, then UT will be downward. So if I want to represent UT, this is UT, and UN is perpendicular to UT, directed towards the center of curvature. So it will be like this. And of course, VA and UT are always of same sense because UT is defined as unit vector of V. Now, since they said that I have increase in speed, so I am accelerating, this means that my tangential acceleration will be also along UT. So this is tangential acceleration will be downward, of course, here because I have acceleration. And AT is given, okay, AT is equal to 2, I know it. And the velocity also is given, V is equal to 6. And what I want to find now, first, I want to find the direction of velocity. How can I find the direction of velocity? Who will tell me? Direction is given by angle. So I know that it's downward, okay? And this is the line of action of the velocity. Now, what I still need to find, I know that it's, the vector is downward. I still need to define completely the direction. I need to find this angle, okay? The angle of the tangent with x-axis. How can I calculate this angle? Who can tell me? How can I find the angle theta here? نحن عنا الفانكشن صح؟ عنا the function of parabola. You know from math that when you have a function and what will be the angle between the tangent and the horizontal axis? كيف بنجيب الانجل؟ The slope. The slope اللي هو tangent of theta, okay, can be calculated by is equal to dy by dx, the derivative of y with respect to x. Okay, so this will give me the slope of the tangent at any point of interest. So here first I will derive y with respect to x. Y is x squared over 20. So the derivative will be 2x over 20, which is x over 10. So when I derive, this is equal to x over 10. Now, concerning the value of theta at point A. At point A in particular, what is x? As you can see here, x is 10 meters. Okay, so to find theta A, I can say that theta A, so theta at point A will be calculated as tangent minus 1 of x of A over 10. Okay, so tangent minus 1 of 10 over 10, I will just replace xa by 10. I get 10 over 10, which is 1. Okay? What is tangent minus 1 of 1? It is 45 degrees. So I can deduce from here that the velocity is doing an angle of 45 degrees with the horizontal axis. Okay? So the angle here is 45. So in this way, I found the direction of velocity. Now, the second question is to determine the direction and magnitude of acceleration. Now, whenever I have curved motion, I should pay attention that my acceleration will be divided into two components. One along UT, one along UN. Already, I know AT. Okay, so the component along UT is already known. AT equals to 2. I still need to find what? I still need to find the component along AN. Okay? So how to calculate AN? We have seen together that what is the formula for AN? The formula for AN is V square over rho, where V is the velocity at the point, and the velocity here at the point is given VA equal to 6 meters per second. And the second parameter is rho. How to calculate rho at point A? What should I do here?
نستعمل الفورمولا اللي هلا أخذناها.
Yes, very good. تعمل Yeah, just one second لأنه هو عم يعمل auto saving when I'm taking notes. خلينا نروح على Do you know sheet اللي كنا عم نشتغل عليها أول شيء؟ برمت سكرين عندكم؟
Yes.
Okay. So they gave me the function. I know that y is equal to x squared over 20. Sorry guys, قطع الconnection. Do you hear me now?
Yes, doctor.
Yes.
Yeah. So let us continue. Okay. So we were saying that they gave us a function. Let me check. No, it's still recording.
Yes, بس دكتور مانك عاملة share screen.
يلا I will. Okay, so we were talking about how to calculate the radius of curvature at A. Okay, you know that on a curve, at any location, I am moving on a small arc of circle. مظبوط? So this will correspond to a certain circle at this location. هذا الcircle الراديوس تبعه بنسميه radius of curvature. Okay, and to calculate rho at A, at point A, the radius of this circle, I will apply the formula we have seen above. Okay, رح ارجع على الفورمولا. The formula is 1 plus dy by dx square. السكوير هو بس ل dy by dx وكلها سوا يعني 1 plus dy by dx square the power 3 over 2 over the absolute value of second derivative. بياخدوا the absolute value of the second derivative because rho is a positive number. Okay, so here for example in this example لقينا أنا وياكم إنه what is dy by dx? It's x over 10. مظبوط؟ نحن in particular we are interested بpoint A. So dy by dx بالproblem تبعنا at A, okay, is equal to 10 over 10 is equal to 1. So equals to 10 over 10 equals to 1. Okay, and the second derivative is 1 over 10. The second derivative is 1 over 10. So this at point A, this value is replaced by 1 over 10. Okay. So now I can just replace in the equation and find the value of rho. Okay. So it will be 1 plus 1 to the power 3 over 2 times 10 لأنه هيدي 1 over 10 تطلع لفوق. Okay. So in this way I can calculate rho at point A, and once I find rho at point A, then I can calculate the value of AN. So here you can see all details. First, to get the angle of B with the horizontal, I do tangent minus 1 of dy by dx اللي هي 1. هون بس زيدوا 1. It's tangent minus 1 of 1. It's 45 degrees. And concerning the acceleration, to find the AN, we should calculate the radius of curvature. So we replace dy by dx by 1 and the second derivative by 1 over 10. We get the value of rho. And once we get all of this, we can calculate now the acceleration. The acceleration, as you know, has two components, AT and AN. AT is given in the problem because they said it's increasing at 2 meters per second square. So AT is 2. And AN is V square over rho. Okay. So now by replacing, I can find the value of AN. Now, we are not done yet because they asked for the magnitude and direction. Okay. So first, to get the magnitude of acceleration, I just do radical of 2 square plus 1.273 square. And how to calculate, how to find the direction of my total acceleration. So let us see here a small representation of A. Okay. So as you can see, this is AT equal to 2. This is AN equal to 1.273. I can draw the resultant acceleration. Okay. Now, the resultant acceleration, to know its direction, I can first find its angle with or UT or UN. Okay. So for example, here, if I decide to find its angle with UN, then I can say that tangent of phi is 2, which is AT, over 1.273, which is AN. This will give me the angle phi. Okay. But in general, we don't give angles with variable directions. Yani UN UT will vary with the instant. So in general, when we give an angle, we give it with a reference, a fixed reference. عادة بتكون أو horizontal أو vertical. So here, if I want to give the angle with the horizontal line, this is my horizontal line, okay? This is my horizontal line. And already, I know that UT is doing an angle of 45 with the horizontal, okay? So since UT is doing 45 with the horizontal, and UT is perpendicular to UN, يعني هون عندي 90 degrees, okay? قد حيبقى للانجل هون from this side between UN and the horizontal. هيكون الانجل كمان between UN and the horizontal equal to 45. مظبوط؟ So this is 45 degrees here. فأنا الانجل اللي بدي اجيبه هو الانجل between the acceleration, total acceleration and the horizontal. So how can I get it? أنا بعرف the total angle هو 5 and I know that this part between the horizontal will UN هي 45. Okay, so I can deduce that the small angle that I want to calculate اللي هو between total acceleration and the horizontal هو equal to the total angle هيدا اللي هو calculated 5 minus 45. Okay, this will give me the angle I want here. So I deduce that the angle of A with the horizontal is 5 minus 45 equals to 12.5 degrees. هلا صرت أعرف كل شيء عن A. So if I want to represent A, I can just represent it by a vector like this, having an angle of 12.5 degrees with the horizontal and a magnitude of 2.37. Okay. Any question on this? Okay. Let us start with another problem. The race car C travels around the horizontal circular track that has a radius of 90 meters. If the car increases its speed at a constant rate of 2.1 meter per second square, starting from rest, determine the time needed for it to reach an acceleration of 2.4 meter per second square. What is its speed at this instant? So here, we have a car moving on a circular track, okay? And they gave us several information. The first information is that the radius of the circle is 90 meters. They said that it is increasing its speed at a constant rate of 2.1. 2.1 so represent what? This is what?
80. Tangential.
Exactly. It is 80. So I can say here that 80, which is tangential component, is equal to 2.1. And the radius of rotation is given to be 90 meters. Now, my car is starting from rest. This means that they gave me a boundary condition. So this I will use it to say that at t equals 0, the velocity of my car is 0. Okay, so at t equals 0, v equals to 0. Determine the time needed for it to reach an acceleration of 2.4 meter per second square. وقت يقولوا لي هيدي هي total acceleration. لأنه when they just say acceleration of the particle, this is its total. This is the total acceleration, okay? And the total acceleration has two components, an and at, okay? طيب. How I will use this given. هن طلبوا مني what is the time needed to reach an acceleration of 2.4. First, at is constant, okay? فإذا at is not varying. an will vary, okay? Why an will vary? لأنه نحن بنعرف إنه an is what? By definition, an is equal
over
to
R.
Exactly. R هون fixed. The radius of the circle is fixed. مظبوط. So R is not changing, but V is increasing. لأنه أنا I am accelerating. So because V is increasing with time, then AN will increase with time. Okay? And to find how AN is increasing with time, I should calculate the expression of V. Okay? How to find the expression of V, the variation of V with time?
V equals 2.1 t.
Very good. لأنه نحن بنعرف إنه in general what is the formula for velocity? V equals لأنه AT constant. Because AT constant I can apply the formulas of constant acceleration, tangential acceleration اللي هي V equals to AT times T plus V0. Okay? Now in this equation I will use the boundary condition to find V0. Okay? From the boundary condition, they said at t equals 0, V equals to 0. So if I replace back here, I can deduce that V0 is 0. So my velocity V can be just written as 2.1 times t. Okay? Now, I have V expressed function of time, and I want to find time. Okay? So now all I have to do is to apply the conditions they asked me about. They said determine the time needed for the velocity, for the acceleration to reach 2.4 meter per second square. So I will write that. What is the expression of total acceleration? How can I calculate the total acceleration?
radical AN square plus AT square.
Yes, very good. So I can write that. So the total acceleration square is equal to AN square plus AT square. Okay? Now, they gave me the value of A. A is 2.4. So I will put 2.4 square. So this is equal to 2.4. 2.4 square is equal to so 2.4 square is equal to 2.1 square اللي هي 80. Okay? 2.1 square plus AN square. Okay? Now for AN, I will replace the velocity by its expression. نحن already عندنا AN هي V square over R. يعني AN square حتكون V to the power 4 over R square. مظبوط؟ So I will replace V by its expression 2.1t فبيطلع لي plus 2.1t to the power 4. Okay? Over what? Over the radius square, يعني over 90 square. Now, the only unknown in this equation is the time needed to reach an acceleration of 2.4. Okay? So here, I calculate t from this equation. And once I find t from this equation, what is the speed at this instant? Once I find t, I replace t from here in this relation, I get the velocity. Okay? خليني أفرجيكم solution in a clearer way بال next slides. So as the first step, as we said, we know that A is radical of AT squared plus AN squared, and AT is known. Since AN is function of velocity, the second step is to find V function of time. the velocity can be calculated as v0 plus a t constant times t, and applying the boundary condition, v0 is 0, so we get that v is 2.1 t. Now, by replacing v by its value in an, you can get an function of t, and rho, of course, is 90 meters. Now, once we have the expression of at and an, we can replace in the equation a is radical at square plus an square. أو فيكم تكتبوها تشيلوا الراديكال فيكم تكتبوها a square equal to 80 square plus an square. In this equation, the only unknown is t. You can get the value of t. Okay? And once I find t, all I have to do to find the speed is to replace back in the equation of velocity to get the velocity at this instant. Any question on this problem? Okay. Another problem. So we have boxes traveling along an industrial conveyor. If a box starts from rest at A and increases its speed so that AT is equal to 0.2 t meter per second square, determine the magnitude of its acceleration when it will reach point B. So here we have, in the next slide, we have a detailed figure. So this is the path of motion of my box on the conveyor. We can see that in the first step, the motion of the box is linear, so it's going through a straight line. And then in a second step, the box is undergoing a change in curvature, a change in direction. So it's moving along a curve, and the curve is circular. It's circular of radius 2 meters. Okay. So now, my purpose is to find the velocity and acceleration of the block when it will reach point B. What they told me that from A to B, I have constant, I have the same expression for AT. Okay, so they said that for the whole motion, and starting from A, which is rectilinear, until going through the circular path to reach B, for the whole path, I have one expression of AT. For the whole path, AT is 0.2 t. Okay? And we know that the tangential acceleration is defined as v dot, which is dv by dt. So from here, knowing a function of time, a t function of time, I can deduce the expression of velocity function of time. But I need a boundary condition. In the problems, I said that my box is starting from rest. So at t equals 0, v equals 0. So now I can integrate. I do separation of variables. My two variables are velocity and time. I have dv equals to at dt. I replaced at by 0.2 t. And I integrate the first side with respect to velocity between 0 and v. And I integrate the second side with respect to time between 0 and t. So the integration of the first term is v, because I have here function 1. So it's integral of 1 dv, okay? So which will give me v minus 0 from the first side. From the second side, integral of 0.2 t is 0.1 t squared. So I get my velocity function of time. This is my first step, okay? Why I need to do this? Because the question is to find the acceleration at B. And you know that the acceleration at B is function of the velocity at B. Just let me check if they want the time also. Yes, no, they just want to find what is the magnitude of acceleration when it will reach B. But we will see together that to solve for the acceleration at B, we will need to find the time. Okay, we'll see why. Okay, so here in B, I have I am moving on a curve. So in B, if I want to find the acceleration, I should find two components. I should find acceleration of B in tangential direction, and I should find the acceleration in normal direction. Now, since tangential acceleration is function of time, so to be able to calculate AT, I should first find the time needed to reach B. So I want first to find what is a tangential at B. From here, I need to find the value of TB. Okay? Who will tell me? How can I find the time needed to reach B? Let us look back at the figure. What do I know as information? I know the length of the rectilinear path. So the distance I am moving along the rectilinear path is 3 meters. And I can determine the distance I am moving along the curved path. This distance, how can I calculate it? This distance is equal to what?
Theta times R.
Yes, it's equal to radius times the angle, delta theta. What is delta theta here? It's 90 degrees, pi over 2. Okay, so I can say that if you want here, because we are working in curvilinear coordinate, S, okay, this is S. S represent at any point the total distance traveled. So when I reach B, what will be S of B? S of B is equal to the total distance traveled, which is equal to first the distance traveled during the rectilinear path, which is 3. So SB is equal to 3 plus what? Plus the distance traveled during the second phase, the curvilinear phase, okay? Which is equal to pi over 2, which is delta theta, times the radius. And the pi over 2 times 2, so it will be equal to pi. 2 will simplify, okay? So what can I deduce now? I can deduce that S of B, so when simplifying 2, S of B is equal to 3 plus pi. How can I use this information? It will help me to find what?
V at B.
Yes, it's to find the time at B, okay? My purpose is to find what is the time needed to reach point B, okay? Now, since I got SB, let us find S function of time and then apply at point B. How to find S function of time?
Integral of V.
Exactly. I found that the velocity is 0.1 t squared. And I know by definition that velocity is equal to what? It's equal to ds over dt. Okay, so now if I do separation of variables, I can get the expression of s. Okay, so let us see it in detail here in calculation. So first, I say that S of B can be calculated as 3 plus 2 pi times 2 over 4, which is pi. Then, since SA is 0 and T equals 0, because in the figures they gave me that the origin of S is when I start motion. So I can say that V is ds by dt equals to 0.1 t squared. I take dt to the other side to separate variables. And I can integrate from t equals 0, which corresponds to s equals 0 because I was at the origin of s. And the second boundary is the final time tb. At the final time tb correspond s of b. And s of b is already calculated. It's 6.12142 meters. So I replace it by its value. In this way, when I integrate, the only unknown will be t. So when you perform the integration, what you will get? You will get 6.142 from the first side equals to, from the other side, when you integrate this function, the integral of this function is 0.1 t square over 3. And if you apply it between 0 and tb, at 0 بتطلع 0. So I will get just 0.1 times tb to the power 3 over 3. Okay, then the only unknown in this equation is tb. I can calculate the corresponding value of tb. Okay, so this is the time needed to reach b. Once I get the time needed to reach b, then it will be very simple to calculate the acceleration at b, because first I say that the acceleration of b is divided into two components, AB tangential and AB normal. To start with, AB tangential شو الإكسبريشن تبعها؟ نحن شفنا إنه AB at any time هي 0.2t. So all I have to do now is to replace t by its value at point B. يعني I replace t by tb. I get AB tangential. And now to get AB normal, I need first the velocity at B. To get the velocity at B, I know the expression of VB function of time. VB is 0.1 t square. So I just replace t by its value at B, tb, and I get then the value of velocity at point B. And once I know V at B, AB normal will be equal to VB square over rho. Now what is the radius of curvature? It's the radius of the arc of circle here. And it's given. They told me in the given that this is equal to 2 meters. So I replace rho by 2. I get the value of normal acceleration. And now, since I already know the value of AT and AN, to calculate the magnitude of my total acceleration, I apply the formula radical of AN square plus AT square. Any question on this? Okay. Now, let us continue with another type of frame. Until now, we have considered, if you want, Cartesian coordinates. We have considered normal tangential coordinates. The third type is cylindrical components. Okay? So another possibility to define motion is through cylindrical components. And we will see that in several applications, cylindrical components is a good choice. So, what is the idea concerning cylindrical components? So, instead of dealing with UN UT, okay, another possibility is to choose UR U theta frame. And what is UR U theta frame? In general, when you have a particle moving on a curved path, okay, you can define its position using the following. If I choose a reference line, this reference line is fixed, okay, then I can say that at any location of my particle, to be able to define the location of my particle, I just need two coordinates. I need the angular position, yani the angle theta between the reference line and my position vector. For example, this is theta here. And a second important factor to know is the length of the magnitude of the position vector, which is called R. Okay, so if I know the angle with the reference and I know the magnitude of OP, then I can define completely my position. If I want to use these coordinates to define the position of P, which are called cylindrical coordinates, then I will use a new type of frame. The new type of frame which I will use is UR U theta. What is UR U theta? UR U theta frame is also a frame moving with the particle, with a way that UR is defined as the unit vector of position vector. So position vector here is OP. Its unit vector is UR. So it will be the same direction, same sense, but magnitude 1. So this is UR at point P. So as you can see, at each location, I have a new UR U theta. And this is point 1. I have UR1 U theta 1. At another location, this is, let's say, UR2. And how to draw the vector U theta at stage 2? U theta is always perpendicular to UR. But how to know if it's up or down? I should look at the positive direction of theta. As you can see here, theta is directed positively counterclockwise. Okay, this means that to obtain U theta, I should rotate from UR towards U theta in the counterclockwise direction. So here, I turn 90 degrees from UR to U theta in the counterclockwise direction, which is the positive direction of theta. And in this way, I get U theta at stage 2. Okay, so from here, at each location, I can put the frame UR U theta. This will depend on the position of my point. Now, if I want to work in this type of coordinates, how to define velocity and acceleration? I will go back always to the definition. In order to find velocity, I should derive the position vector with respect to time. And in order to find acceleration, I should derive velocity with respect to time. So here, in this type of coordinates, how to define the position vector? The position vector, as you can see, vector OP, we defined UR as the unit vector of OP. This means what? This means that the position vector can be written as the following. The magnitude of the position vector times its unit vector, and since UR is by definition the unit vector of OP, then vector position OP is equal to its magnitude times UR. And now, since I expressed the position vector function of UR, now I can derive this vector to get velocity, and then I derive velocity to get acceleration. Okay, so let us work step by step to find the expression of velocity and acceleration in cylindrical components. Okay, so as we said, first, to find the velocity, we should derive vector r with respect to time. And since vector r is RUR, okay, this means that I am deriving here, I am deriving vector r times UR over dt, okay? And r times UR, it's like the product UV. So when you derive UV, مثل ما عملنا قبل if you remember to derive velocity بالtangential from normal component, عملنا U prime V plus V prime U. Here also we should do this, لأنه UR is not a constant vector, it is changing in direction. So its derivative is not 0. So here, in a similar approach, when we derive RUR by dt, it's like doing U prime V plus V prime U. U prime is the derivative of R, it's R dot, times V UR, plus UV prime, يعني plus R times DUR by dt. رجعنا لل DUR by dt. مثل ال DUT by dt, same method, exactly same method. So I will repeat it in brief here. Here, you take two close positions, okay? UR prime, okay? And of course, since here theta represents the polar coordinate, which is the angle between the reference line and UR, you can say that at location 1, this is angle theta 1, okay? At location 2, this is angle theta 2. So the angle between UR prime and UR is delta theta, okay? So this is delta theta between UR and UR prime. Now, نرجع لنفس القصة. We have here an isosceles triangle, مظبوط. لأنه magnitude of UR is 1 وmagnitude of UR prime كمان 1. okay, and since it's a very small angle هيدا هناخد نحن a very small angle دي تاتا يعني delta theta tends to 0 يعني I can say that it's equal to d theta. okay, since d theta is very small, then I can say that the magnitude here of this segment is equal to the magnitude of arc of circle is equal to d theta. So the magnitude of DUR, so when I take delta very small, magnitude of DUR is d theta. So exactly مثل ما عملنا بال previous method. Now concerning the direction كمان نفس analogy. I have here an isosceles triangle with a very small angle here. So what will be angle here? 90 degrees. This means what? This means that as you can see in the figure, DUR is parallel, same and have same sense of U theta. This means that U theta who will unit vector of DUR. So what can I deduce now? I can replace DUR vector, okay, is equal to its magnitude اللي هي d theta times what? Times its unit vector. What is the unit vector of UR? It is U theta. So I can replace DUR by d theta times U theta. And since I am interested in DUR by dt, شو رح أعمل؟ I will divide here by dt. And I will divide d theta by dt. So now what will be d theta by dt? It represents what? It represents the angular velocity of rotation. So this is called theta dot. Okay, هيدي theta dot or omega. Okay, and therefore, as we can conclude here, we can define DUR by dt. We can replace it by theta dot U theta. Okay. So going back to my formula here, if I replace UR dot by theta dot U theta, I get that V has two components, radial and هيدا بيسموه transverse component along U theta. بيطلع لي R theta dot U theta. So let me show you. Here's the final expression. So as we said, vector UR can be written as theta dot U theta when delta t tends to 0, and then I will get a final expression of velocity, a velocity having two components, VR and V theta, radial and transverse component. The radial component VR هو R dot dr by dt. بينما if I do comparison with my expression, what is V theta? V theta is R theta dot. Okay. So why here إذا بتتذكروا بالtangential component بس كان عندنا V along UT ما كان عندنا V along UN. Why here it's different؟ لأنه please pay attention. UR is not tangent to the path. مظبوط؟ لأنه نحن UR will depend on the selection of the origin. Here, for example, if you look at this example, UR is not tangent to my path. So when I know that my vector velocity will be always tangent to the path. So if I want to decompose it in UR U theta frame, هيكون عنده two components. One along UR اللي هو بسميه VR radial component, and one along U theta اللي هو بيسموه transverse component. Okay, and VR is function of variation of R. يعني this is why VR is R dot. Okay, dr by dt. If R is varying, then I have a radial velocity. If R is constant, then VR will be 0. Okay. Now the second component is the transverse component. The transverse component here is due to what? Is due to change in direction. Because when theta varies, this means I am changing in direction. I will have theta dot and I will have theta. Okay. So In this way, I have calculated the expression of velocity in UR U theta free. And as you can see here, I can calculate the magnitude of V as R dot square plus R theta dot square. Okay? Any question on the velocity derivation before we move to the acceleration? Okay. So now, as the next step, I will find now A. For A, it's a little bit more complex, and I have more terms. Okay? We know that A is the derivative of V. مظبوط? And this is the expression of V. I have already found V. V is R dot UR plus R dot U تحت. صارت شوي طويلة الدريفيشن. Why؟ لأنه أول شيء كان first term. Yeah, just 1 second. Okay. If I consider the first term is of V is R dot يعني dr by dt times UR. If I want to derive this term كأنه عندي U times V. مظبوط? So what should I do? I should do U prime V plus V prime U. The derivative of R dot شو حتكون؟ R dot dot يعني second derivative of R. So the first term حيكون R dot dot UR plus what? Plus UV prime يعني plus R dot DUR by DT أو UR dot. So the first two terms here you can see here whole derivative of R dot UR. Derivative of R dot UR هي R dot dot UR plus R dot UR dot. هيدي أول derivation of radial component of velocity. بيرجع second component of velocity is also more complex. Why? لأنه I have the second term هو R theta dot U theta. Yes.
ما بعرف إذا اللاج بس عندي، بس أنا بعده عندي السكرين frozen.
Okay.
أنا
Look.
كمان.
يلا هفتح هرجع اعمل شير سكرين، هرجع اكتب لكم هون الديريفيشن ان ديتيل تشوفوه. يعني بس 1 second. Okay, so look, I will write here again what we found together. We found that the velocity vector, do you see الفولدر اللي عم بكتب عليه now?
Yes.
Okay, we have seen that the velocity vector is defined as R dot UR, okay, plus R theta dot U theta, okay, plus R theta dot U theta. Now, we know that the acceleration هي derivative of velocity. مظبوط؟ طيب. So if I want to find the acceleration vector now, what should I do? I should derive this term. مظبوط؟ First, I will start by derivative of this term. هأكتب إنه dv by dt اللي هي acceleration is equal to what? First, when I derive r dot ur, it's like I'm deriving a function u times v. When I divide u times v, derivative is u prime v plus v prime v. مظبوط؟ What is u prime? هي derivative of r dot اللي هي r dot dot. يعني my first expression هي r dot dot times ur. Okay. Plus what? Plus r dot dur by dt يعني plus r dot. نحن انا وياكم هلا جبنا دي يو ار باي دي تي، مضبوط؟ مين بيتذكر شو طلعت دي يو ار باي دي تي؟ طلعت تيتا دوت يو تات، مضبوط؟ يعني هلا بعدين when we replace we can replace dur by dt by theta dot u tat. طيب خلصنا من الدerivative of the first term, and when you derive this you will get these two terms. Okay, second step, we will derive the second term now. The second term في 3 components r و theta dot و u tat، يعني كأنه عنا u v w. If you want to derive u times v times w, شو الفورمولا؟ u prime v w plus u v prime w plus u v w prime. اوكي؟ يعني أول شيء أول term شو حيكون؟ حيكون derivative of r with respect to time times the other variables. يعني أول term حيكون r dot times theta dot times u tat. Okay, this is the first term of the derivation. The second term of the derivation هلا بعمل u v prime w. يعني now it's the turn of theta dot. Okay, so plus r theta dot dot u theta. This is the second term. Okay, now the third term هو plus r theta dot du theta by dt. مظبوط. So the final term is plus r theta dot times u theta dot. Okay, times u theta dot. Okay, طيب هلا لقينا total derivative. Okay, now we will start to replace the terms اللي بنعرفها. Okay, what is ur dot؟ هلا جبناها انا وياكم. شو كانت الفاليو تبعها؟ كانت الفاليو تبعها theta dot times u theta. يعني I can replace ur dot by theta dot u theta. اوكي، وشو في عندي شيء ثاني هون؟ عندي u theta dot. مين بيقول لي شو حتكون u theta dot؟ شو حتكون u theta dot؟ ارسم فيجر صغيرة هون. اوكي، this is the original. مش نحن قلنا انه عندنا two positions. This is ur1. Okay, this is u theta 1. برمنا a small angle d theta. صار عندنا new vectors ur u theta. So وقت برمنا صار عندنا new vector ur. new vector u theta like this. اوكي، طيب خلينا نشوف شو بنلاحظ هون. قلنا انه الفيكتور دي يو ار، وين الفيكتور دي يو ار؟ عندنا هيدي يو ار 1. This is ur1 and this is ur2. Okay, and this is u theta 1 and this is u theta 2. Okay, we have that the angle here between ur1 ur2 شو سميناه؟ سميناه دي تاتا. اوكي، واكيد انتم بتعرفوا لانه u theta perpendicular u theta 1 perpendicular ل UR1 و u theta 2 perpendicular ل UR2 فكمان الانجل بين اليو theta 1 واليو theta 2 حيكون دي theta. طيب شفنا انا وياكم انه دي يو ار هحطه بالجرين دي يو ار is this vector مظبوط this is vector دي يو ار وثبتنا انا وياكم انه الماجنتيود تبعه دي تاتا ولانه هو parallel وعنده same sense of u theta فقلنا انه دي يو ار vector can be written as this is DUR. DUR can be written as theta dot times u theta. مظبوط. So DUR can be written as theta dot times u theta. Okay. Now شو بدي اجيب انا؟ بدي اجيب دي يو تاتا مش دي يو ار. Where is دي يو تاتا in my figure؟ هحطها بالبلو. This is دي يو تاتا. It's here. مظبوط؟ This is vector دي يو تاتا. As you can see إذا بعمل analysis أول شيء كماجنتيود حيكون كمان equal to 1 times دي تاتا. بس شو حيصير بالdirection تبعه؟ طلعوا منيح هو perpendicular ل u theta يعني parallel ل UR مظبوط بس إذا بتلاحظوا هو opposite ل UR يعني منهم same sense عندهم opposite sense okay so because they have opposite sense what can I write here unit vector تبع du theta هو minus UR so I can write that vector du theta is equal to minus theta dot UR okay minus theta dot UR يعني هلا I can replace in my expression I can replace vector du theta so let me write it here du theta is equal to minus theta dot times UR okay so now يعني هي ذات derivation بس الفرق انه it's opposite they are opposite sense so بدل ما اكتب plus theta dot unit vector it's minus theta dot لانه الunit vector هون هو minus UR مش plus UR so now all I have to do is to replace u theta dot here I replace it by minus theta dot UR and now what I will do I will take all components of UR together and all components of u theta together هنشوف شو بيطلع لنا okay so here in total عندكم components along QR components along u theta okay so I can write now that my acceleration vector to find its component along UR u theta I will write that A vector is equal to I will sum all UR components together. What are the UR components? أول component هو R dot dot UR. Okay. وتاني component في UR هو this one اللي هو R theta dot times minus theta dot UR. This is the second one. Okay. So in total, what do I have along UR? In total, I have R dot dot. Okay. Minus this one is R theta dot times theta dot يعني minus R theta dot square so minus R theta dot square this is the radial component of acceleration okay and now to find the transverse component of acceleration I will sum the u theta expressions so I have the first component along u theta is this one اللي هو r dot theta dot u theta ولاحظوا انه عندي same component كمان، يعني عندي 2 times، عندي r dot theta dot u theta plus r dot theta dot u theta، فححطه 2 times plus 2 times r dot theta dot plus I still have one component along u theta اللي هو r theta dot dot, so it's plus r theta dot dot u theta. Okay, so now I can deduce that my acceleration has a radial and transverse component. The radial component is, this is called AR, okay? AR is r dot dot minus r theta dot square. And this is the transfer component A theta. A theta is 2r dot theta dot plus r theta dot dot. Okay, so any question on this? So if I go back to my, do you see the PDF again now?
Yes.
Okay, so if I go back to my derivation, okay, as you can see here, they derived the acceleration with respect to time. They got different components, and by summing our components together and theta components together as we did, they obtained that AR is r dot dot minus r theta dot square, and A theta is r theta dot dot plus 2r dot theta dot. You don't have to memorize anything because it's an open book course. So in the exam, you can have your notes in front of you. Just you should understand how to use these formulas. Okay? So this is the expression of acceleration. To find the magnitude, of course, we can do radical of AR square plus A theta square. And as you can see here, this is the decomposition of acceleration into radial transverse components. And A is also, you know that A is not tangent to the path, V is tangent to the path. So here A will have two components, one along AR, one along A theta. Okay. Okay, now what we will do now is just we will extrapolate from 2D case to 3D case. Okay, so in case you have a motion in 3D, you can still use the polar coordinates by adding, if you want, another coordinate. The other coordinate to add is the elevation. Okay, so you will, if you have any point P, what you can do is you can project on a horizontal plane. Then you have first, when you project on a horizontal plane, you will get the value of elevation Z. Okay, and in the horizontal plane, instead of dealing with X and Y, you replace X and Y by theta and R. Okay, so the only difference, if you want, between 2D and 3D is that I add the elevation factor Z. Okay, but R and theta are still defined in the same way. R and theta coordinates, if you want, will replace X and Y coordinates in Cartesian frame. Because in Cartesian frame, if you have X, Y, Z, okay, once you project your point on XY plane, you can read X and Y. Now, instead of expressing X and Y, you can express polar coordinates, which are R and theta. And of course, you can relate X, Y to R and theta, as you can see here. Because if I know R and theta, I can deduce the values of X and Y. Because if I do the projection here, okay, I can say that X is what? I can write that X is equal to R cosine theta, okay, and Y is equal to R sine of theta. This means that r and theta are coordinates replacing x and y. So I can use cylindrical coordinates in 3D, and they will be r, theta, and z. Okay? So now, in this type of frame, in r, theta, z, if I want to express the position vector, what will be the expression of my position vector? If you look at your figure, you divided your position vector. This is your position vector here. This is RP, okay? Your position vector is divided into two components, one along UR. So this is the component along UR, okay? And this is the component along K or UZ if you want, okay? So I divide in way my position vector into RUR and plus ZUZ. As you can see, UZ here is the vertical vector. Okay. هلا of course مش ضروري على طول يكون vertical. يعني إذا عندي inclined cylinder باخد UZ parallel to the axis of the cylinder. So it depends on the geometry of my problem. But UZ is perpendicular to the plane of UR theta. Okay. So here I get that the position vector is RUR plus ZUZ. So now for the velocity expression هتكون نفس الشيء مثل قبل, just I should add what? يعني in addition to the derivation of RUR اللي هي R dot UR plus R theta dot U theta, I should add the derivative of ZUZ. Okay? But why the derivative of ZUZ is much easier? لأنه UZ is a fixed vector. It's not moving, it's not changing. Okay? Why it's not changing? لأنه هي what is the idea? UR U theta هيغيره with the particle, but UZ will always be perpendicular to UR U theta plane. Okay? يعني UR U theta will change in direction, but will stay in one plane. Because they will stay in one plane, UZ, which is perpendicular to this plane, will not change in direction. So it's a fixed vector. And because UZ it's a fixed vector, when I derive UZ with respect to t, it's 0. So when you want to derive ZUZ, it's just Z dot UZ. You don't have to derive UZ with respect to time because it's a constant vector. So when you derive it, it is 0. So it's plus 0. Okay? Therefore, the velocity component will be equal in 3D, will be R dot UR plus R theta dot U theta, which is already obtained in 2D. Just we should add to it Z dot UZ, which represents the velocity of motion in UZ direction. Okay. Now, in case Z, the elevation is not changing, in case Z is constant, so I'm moving in one plane, then the velocity will be restricted to the first two components. And now, for acceleration, it's similar also. So for acceleration, I will obtain first AR, which is the same expression as before, A theta, which is the same expression of before. Just I should add now the derivative of this term. And as we said, UZ is constant. So when you derive Z dot UZ, you will obtain Z dot UZ. So in 3D, these are the expression of V, A, and position vector. Any question on this? Okay, so now, in general, pay attention a lot for, in case of cylindrical coordinates, the majority of time, they give us R, the position vector R, function of theta. So pay attention that when you want to derive R with respect to time, you should use the chain rule, okay? So dr by dt will be equal to dr by d theta times d theta by dt. So we will use a lot the chain rule in calculation of cylindrical compounds. And you will practice on this together in problems, okay? So I will stop for here for today. Next time we will do together problems on cylindrical components. If you have any questions before we close, I can answer your questions. Any question on what was explained today? Okay, so next time we will continue to solve these problems. As as I said to your friends yesterday, I will post for you review problems during today or tomorrow. Okay, you can start to solve review problems, and I will correct them with you next week when we finish the chapter. So for each chapter, we will do always course material first, then we will do review problems on it. Okay.
Deal, doctor.
So if no, okay, guys. So we meet next time. Okay. Yeah. Bye.
Merci دكتور يعطيك العافية.
Merci. Bye.